All right, this is Mr. G Math coming at you live all alone after you guys did that test. And I know it's not easy to take a test Monday morning. We'll get through it. Lesson 7.1, exponential functions. This is all a review 7.1, no calculus involved, just a pre-calculus review. So in the box shows different rules, laws of exponents, anything to the exponent 0 equals 1. Look at each law in terms of adding, subtracting, multiplying. What a negative exponent means reciprocal. Here, notice that you can't do this. Obviously, you have to expand it properly. All right, let's look at number 1 through 5 and be able to simplify without using a calculator. So what does a fractional exponent mean? So it means two parts. One, the denominator is the root. So what is the cube root of 27? So that's 3. And then the power gets applied to that answer, and it's 3 to the exponent 4 is 81. Here, anything to the exponent 0 equals 1, so we don't worry about it. Here, we can simplify the e's first. So 5 take away 3 is 2, and then subtract leaves me with e to the negative 2, if you like, which is e to the negative 4, or you can think of it as 1 over e to the 4. Number 4, in order to combine this together, we're going to make the bases the same. So 25 is 5 squared to the negative 2. So it's 5 cubed times 5 to the negative 4. Add these together, that's 5 to the negative 1, which is 1/5. Solve 9 to the x equals 27 without using a calculator. By doing that, we're going to create common bases. 9 is 3 squared, and there's an x there. 27 is 3 cubed. When the bases are the same, let the exponents equal each other, and then solve it. So it's 3 over 2. It says use a calculator to carefully graph y equals 2 to the x, and y equals 5 to the x, and y equals e to the x in the same coordinate plane. Do you see any similarities to the graph? So 2 to the x, 5 to the x, e to the x, the similarities is they all go through that 1, 0, 1. When you have 0 for an exponent, the answer is always 1 no matter what the base is. But some of these increase more rapidly than others. So if you look carefully, 5 to the x increases the fastest, obviously. But notice here to the left, they have the same left-end behavior. 2 to the x, e to the x. E approximately is like 2.71 if you're going to approximate it. So 2.71 increases a little bit faster than that. So the middle one increasing. So the first one is y equals 5 to the x. This one is y equals e to the x. And then the one that's just a little bit slower than that one would be y equals 2 to the x. They all have the same left-end behavior, and they actually all have the same right-end behavior. The left-end behavior, the limit down there is 0, and the right-end behavior here goes to infinity. So there's a horizontal asymptote here. So the limit as x approaches negative infinity would be 0, and the limit as x approaches positive infinity would be infinity or doesn't exist. All right, let's look at some points about graphing exponential functions. The domain for it is all real numbers. So that means negative number, 0, positive number, they all work. But the range, you can see the horizontal asymptote. You'll never get the answer 0 or a negative number. So that means the range is greater than 0. Or from 0 to infinity, 0 is not included. The graph is continuous. It goes forever left to right. It's increasing all the way through. It's concave up all the way through, smiling. It's 1 to 1, so it has an inverse. What's the inverse of an exponential? You should know it, but we'll get to it in this unit, what the inverse of an exponential is. Number 3, the x-axis is the asymptote. So you can see the limit going to the left to negative infinity is 0. The limit going to the right is infinity or doesn't exist. The y-intercept is 0, 1. And another key point would be 1 and a, where a would represent the base. So if it's 2 to the x, a point would be 0, 1, but the other point would be 1 and 2. So that base gives you another key point. So you have 2 points to curve through when we do it. All right, turn the page. All right, the letter E used as a base in example 2, 3, and 6 is not an unknown, but rather an irrational number. It's called the natural base. I said it's approximately 2.71. It is the most common base in calculus. And there's a good reason. The next section, 7.2, 7.3, you will see that the base E is so beautiful because it's so simple in terms of derivative integration. So anyways, base E is used almost all the time because it's so simple to use in calculus. By definition, it's this, which is fine, and again, it's approximately 2.718, and so on. All right, so without using a calculator, sketch a graph of y equals e to the x. So if we wanted a couple points, we already know that 0, 1 is a point. The other point would be at 1 and 2.7-ish. So 1 and 2.7-ish. You know, in terms of this, that it goes on forever to the right, goes down left, and approaches 0, but never touches it or crosses it. Using adjustments to the graph from this one, could you graph e to the negative x plus 1? Well, if we took 2 points that we know from the parent, which is 0 and 1, and 1 and 2.7, and I adjusted them, what's in the exponent affects the x-coordinate. So the inverse of what I see up there, we're going to divide every exponent by negative 1. So 0 divided by negative 1 stays 0. 1 divided by negative 1 becomes negative 1. Adding 1 on the outside only affects the y-coordinate. So just the y-coordinate, 1 plus 1 is 2, and 2.7 plus 1 is about 3.7. So I'm going to go to 0 and 2, and negative 1, and about 3.7. And then through that, I'm going to connect and see the curve. Now, I also want to know that instead of y equals 0 being the horizontal asymptote, that has been raised up. So every y value is going to be added, 1 will be added to it. So now it's not at 0, it's now at 1. So I'll draw that in so that when we draw it, we can see the right and left end behavior. And that's it. So the rest of assignment 7.1 is to practice pre-calculus skills to do with exponentials. That's why it was not a big deal for you to go home and look at 7.1 by yourself and watch the video, have some confidence, look at the look at the solutions packet. Hopefully it makes you feel secure. And then when I see you on Wednesday, we're going to have a quiz on this. And then on Friday, we'll just continue on with that. All right. Mr. G Math, over and out.